Alright, Algebra 2, welcome back after Easter break. We're going to move on from exponential functions to logarithmic functions. And logarithmic functions are the inverse of exponential functions. We're going to see why in a second. Now when we have something like a to the x equals b, that is an exponential function. That is equivalent to when you have the logarithm of base a, note that we call this a base as well, of a number b, and that will yield the exponent. So this is when you have a base and you have the value, but you may not know what exponent it's raised to, and you're wondering, what is this number raised to give me this value? Or what is the base that's raised to a certain exponent to give you a value? So the little a underneath the log, that's my base. This is the number I'm taking it of, and this is my exponent. So our first question, which is very similar to your questions that you're going to see in your workbook, are write each equation in logarithmic form. So first you want to write underneath it our logarithmic equation. So a to the x is b. Well, that's the same thing as log base a of b is equal to x. So 8 is a. So I can write 8 in the a spot. My b is 512. And my x is 3. So we're saying 8 to the third power is 512. Or in other words, the base of 8 goes into 512 when it is cubed. 8 cubed is 512. So really we're just first working on writing the form correctly. All right, number 2. We have 1 over 81 equals 1/3 to the fourth. So this is the same as b equals a to the x. So just make sure you're aligning the a to the x side with the side you have an exponent on. Then we write log base a of b equals x. Well, in this case, a lines up with 1/3. B lines up with 1 over 81. So the question is, 1/3 raised to the what power gives me 1 over 81? 4. X is 4. So log base of 1/3 of 1 over 81 equals 4. The next one deals with a negative exponent. So we have 1/6 raised to the negative 2 is 36. That might seem weird at first until you remember that what a negative exponent does is it flips what's in the numerator and denominator. So just a quick check of this. 1/6 to the negative 2 is the same thing as 6 over 1 to the positive 2, which as we know is 36. So it's not that bizarre. Now the goal is to get it into our logarithmic form. Okay, a in this case is 1/6. B in this case is 36. And our exponent is negative 2. We did that just by lining up what's a, what's x, what's b. Then we have something like 10 to the negative 4. Now the 10 ones are special because, we're going to see in a second, if we don't have a base written, that means there's a secret 10 right there. So in this case, a is 10. If a is 10, you could write a 10, but actually I don't need to write a 10 because when there's no 10 written there, we assume that it's a 10. And then b is 0.001 equals x, which is negative 4. So this is saying 10 raised to the negative 4th power is 0. Oops, I missed a 0. 0.0001. Okay, the next option is you might be asked to evaluate the logarithm. That is when you are given a logarithmic equation and you have to find the unknown exponent. Make sure you can see this well. Okay, so log base 2 to the 32. Really, this is saying 2 to the something is 32. And what's that something? So there are some options. You can either just try to figure it out, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5. So 2 to the 5th is 32. Another way you could do it would be to type in your calculator or into Google log base 2 of 32. So if you type into Google log 2 of, in parentheses, 32, then it gives you 5. So that's how Google understands it. If you type it as log 2 parentheses 32, that's how it understands log base 2 of 32, and it will give you 5. For this one, there's nothing written, so we assume it's a 10. 10 to the something power, 10 to the x, is 1,000. So 10 raised to the first power is 10. 10 raised to the second power is 100. 10 raised to the third power is 1,000. So we'd see it's 3. Now, something else we could have typed in to Google is log 10 parentheses 1,000. We also get 3 by typing log 10 of 1,000. So we could have also typed into Google log 10 1,000. We would have also gotten 3. All right, number 7. So log base 4 is 1 over 64. So 4 to the something is 1 over 64. Since it's 1 over 64, we know for sure it's going to be a negative value, since that's what gets our value in the denominator. Now 4 squared is 16 and 4 cubed is 64. So this should be negative 3. Now in case you did want to use it on your calculator, you could type in log 4 1 over 64 into your O. It's going to end up giving you a, it's going to be confused. What I would do then is just type in log 4 of 64. And it will end up giving you 3. And it will end up giving you 3, and then you need to know to make it negative based on the fact that it's in the denominator rather than the numerator. Okay, last but not least, log base 5 of 5 to the 6th. Really what this is saying is 5 to the what power is 5 to the 6th. So we really don't need a calculator for this one, because I know 5 to the 6th is 5 to the 6th. This is kind of a silly one, but it's saying log base 5 of 5 to the 6th is 6. So these kind of outdo each other. That's why these are inverse operations. That's why the logarithm and the exponential functions are inverse.